Right now, while you're watching this, the ground under Southern California is doing something it hasn't done in decades. 3 separate earthquake swarms have hit the region in under 2 months. 3. And they're not scattered randomly across the map. They're lining up, one after another, moving in a specific direction, like dominoes falling down a single line. Geologists are watching this closely, and 2 new studies published just this summer are part of why. Let's start with the newest development because it's still unfolding. On August 20th and 21st, 2026, a swarm of earthquakes began rattling the Coso volcanic field in Southern California. By that Friday afternoon, the USGS had logged 7 earthquakes there, the strongest a magnitude 3.4. Within a week, the swarm had grown to more than 240 earthquakes, the largest reaching magnitude 4.0. On its own, a 4.0 doesn't sound like much, but Coso isn't just a fault zone, it's an active volcanic system with magma underground, geothermal vents, fumaroles, and one of California's largest geothermal power fields sitting right on top of it. A 4.0 in a volcanic system carries a different kind of significance than the same magnitude in open desert. It can mean something underground is actively moving or pressurizing. The California Volcano Observatory has stated there's no ground deformation and no signs of an imminent eruption, and the alert level remains normal. That's the official position, and it's worth taking seriously. But the swarm is also still accelerating rather than tapering off, which is exactly the kind of pattern seismologists keep an eye on. Here's what makes this genuinely notable. Coso is the 3rd swarm in a sequence, and the order they happened in tells a story. Go back to July 12, 2026. A magnitude 4.1 struck right at the junction of the San Andreas and Garlock Faults near Frazier Park, 2 of the most significant fault systems in the country, meeting at a single point. Seismologists identified the rupture as likely occurring on a smaller connecting fault that mechanically links the 2 together at a depth of about 13 kilometers, with a reverse fault motion indicating compression. Then the very next day, a second swarm ignited about 17 kilometers west of Johannesburg, directly along the Garlock Fault. The strongest quake hit magnitude 4.3, with 28 earthquakes in the first 10 hours alone, and by the time it wound down, more than 450 total earthquakes had struck that stretch since June, making it the most energetic of the 3 swarms by total count and released energy. Now put those 3 on a map. Frazier Park sits at the western end of the Garlock Fault, where it meets the San Andreas. Johannesburg sits in the middle of the Garlock system. Coso sits at the eastern end of that same corridor, right where the Sierra Nevada begins. The swarms are marching eastward, tracing the exact path of a connected fault system, and that kind of migration typically reflects stress being redistributed from one section of a fault network to the next, each swarm nudging a little more pressure onto whatever comes next in line. That brings us to 2 studies that landed within weeks of each other this summer, and together they reframe how dangerous this entire fault network might actually be. The first came out August 20th, 2026, from a team at San Jose State University led by geologist Kim Bliznyuk. Her team spent years studying the Santa Cruz Mountains section of the northern San Andreas, using high-resolution mapping and beryllium-10 dating, a technique that lets researchers reconstruct roughly 10,000 years of fault movement from the geology itself, far beyond the roughly 1,000-year window most prior studies relied on. The long-standing assumption was that as the San Andreas runs south, it slows down because motion transfers onto neighboring faults, like the Hayward and Calaveras, meaning the Santa Cruz Mountains section should be creeping along more gently. Bliznyuk's decade-scale data said otherwise. The fault doesn't slow down there at all. It keeps moving at essentially the same rate as sections further north. That means previous hazard models have likely been underestimating how much strain has been building in a section of fault running directly past Silicon Valley and the San Francisco Peninsula. The second study, published in June 2026 in the Journal of Geophysical Research by researchers at the University of Hawaii, looked 1,000 years into the past along the southern San Andreas and San Jacinto fault systems near Los Angeles, reconstructing how stress had built up and released over centuries. Their conclusion was stark. These fault systems are now holding more pent-up stress than at any point in the last 1,000 years, a state the authors called critically loaded. One specific segment, the San Jacinto-San Bernardino stretch, registered a stress reading that exceeded the previous peak recorded roughly 50 years ago. Geologist Matthew Weingarten, who wasn't involved in the study, put it plainly. We talk loosely about faults being overdue, but seeing an actual physics-based estimate placing the system at a 1,000-year high is different and notably more concrete. So here's where that leaves the picture. The northern San Andreas is moving faster than models assumed. The southern San Andreas and San Jacinto are under more stress than they've carried in a millennium. And 3 earthquake swarms have fired off in under 2 months, tracing a path across the fault corridor connecting all of it. It's worth understanding what a swarm actually does to the surrounding fault network, because that part often gets lost. Swarms don't just release energy locally, they redistribute stress onto neighboring locked sections, the way squeezing one part of a wet sponge pushes water into another. The The Garlock Fault, sitting in the middle of all this current activity, has not produced a major surface rupturing earthquake in recorded history. Its last known major ruptures are estimated around 1050 AD and 1500 AD. Its potential maximum magnitude is estimated between 6.8 and 7.6, and it had been essentially silent for generations until it started creeping for the first time on record after the 2019 Ridgecrest earthquake sequence detected through satellite radar. Following Ridgecrest, the USGS noted increased odds of a magnitude 7.5 or greater event on the Garlock. Now, in 2026, swarms are firing repeatedly along its exact path. A Garlock rupture would directly hit communities including Mojave, Johannesburg, Tehachapi, and Frazier Park, with strong shaking reaching the San Fernando Valley, Santa Clarita, Lancaster, Palmdale, Ventura, Oxnard, and Bakersfield, along with Edwards Air Force Base and the Naval Air Weapons Station at China Lake, right next to where the current Coso swarm is happening. And the University of Hawaii study specifically flags a scenario where the Garlock and southern San Andreas could rupture together through the stress configuration near the Cajun Pass Junction, an event that would be considerably larger than either fault, producing a rupture on its own. This kind of pattern isn't unprecedented in California's history either. Major earthquakes elsewhere along the Pacific Ring of Fire have repeatedly preceded major California earthquakes by months. Before the 1906 San Francisco earthquake, a magnitude 8.8 struck the Ecuador-Colombia coast just 3 months earlier, the largest ever recorded in that region. Before the 1952 magnitude 7.5 Kern County earthquake, Japan had been hit by a magnitude 8.1 that same year, and a massive quake struck Tibet months before that. Before the Hayward Fault's 1868 rupture, Hawaii recorded its largest earthquake in its history that same year, followed by an 8.8 to 9.1 event in Peru, and a burst of magnitude 7 activity in Ecuador and Colombia, all within months of each other. This is a documented, studied pattern of regional seismic clustering, not proof of prediction, but a real basis for elevated attention when Venezuela recorded a significant double earthquake sequence in June 2026 on a transform fault system seismologists have directly compared to the San Andreas in structure and mechanics. None of this means a major California earthquake is happening on any specific date. That kind of prediction remains scientifically impossible. But earthquake hazard, the probability that conditions are primed for a major event, is measurable. And right now, several of the metrics scientists use to measure it are elevated, some to levels not seen in the recorded history of earthquake science in this region. It's worth understanding what's actually at stake if the southern San Andreas does rupture. A USGS modeled scenario for a magnitude 7.8 rupture on the southern San Andreas projects nearly 2 minutes of sustained shaking across a corridor stretching from central California to the Mexican border. With an estimated death toll near 1,800, roughly 50,000 injuries, and over $200 billion in damage, making it around 60 times more powerful than the 1994 Northridge earthquake, which killed dozens, lasted 20 seconds, and still caused nearly $40 billion in damage. Layer in the University of Hawaii studies warning about a possible combined Garlock-San Andreas rupture, and the scale could exceed even that scenario. Caltech seismologist Lucy Jones has noted that the San Andreas, as California's longest fault, is capable of the largest earthquakes in the state, and has drawn direct comparisons between the 2026 Venezuela earthquake and what a San Andreas rupture would look like mechanically. The last major rupture on the southern San Andreas was in 1857, of magnitude 7.9, 169 years ago. The last magnitude 7.0 or greater anywhere in California was Ridgecrest in 2019, 7 years ago, during which the plates have continued grinding past each other at several centimeters a year with no major release. So here's where things actually stand. 3 swarms in under 2 months, tracing a line along a connected fault corridor. 2 independent research teams working on opposite ends of the state, both concluding the same thing. The San Andreas system carries more risk than previously modeled. A historically silent fault now showing movement for the first time in the recorded era. None of this tells you when. Nobody can. But it does tell you that the conditions are worth taking seriously, and preparedness is the one part of this you actually control. At minimum, keep a 3-day water supply per person, but for a major San Andreas event specifically, aim closer to 2 weeks, since infrastructure in a magnitude 7.5 plus event could leave water, power, and roads unreliable for an extended stretch. Strap your water heater to the wall, secure heavy furniture, know where your gas shutoff valve is, and keep the wrench for it accessible. Build a household communication plan that doesn't depend on cell networks staying up, because in a major earthquake, those networks are typically overwhelmed or damaged within the first hour. And if you live in a soft-story apartment building, common across Los Angeles and among the more vulnerable structure types in a major quake, know that retrofitting programs are ongoing but incomplete, and it's worth understanding your building's status. Millions of people live within shaking distance of the San Andreas, the Garlock, the Hayward, the San Jacinto, and the Calaveras faults, often more than one at once. The data right now, 3 swarms, 2 independent studies both pointing to record-level stress, a fault that's never ruptured in recorded history starting to move, isn't proof of an imminent event. But it isn't background noise either. The Coso swarm is still active as this is being recorded, and after watching the progression from Frazier Park to Johannesburg to Coso, it's a fair question to keep asking what comes next.